Many of us will be familiar with these surface mount components. These are WS2812, commonly referred to as Neopixels or addressable RGB LEDs. So these are a 5mm by 5mm component. They're relatively difficult to solder by hand. So most people will only have used them when they've been mounted onto a flexible or rigid PCB in long ribbon strips or round or square, different types of shapes. So over the Christmas holidays, I was browsing AliExpress and I came across this new type of Neopixel compatible LED called the SK6812MINI-E. So it's a 3.2 by 2.8mm LED with lead wires sticking out from the sides. So I thought these would be suitable for easy hand assembly, so they might be ideal for using in different types of kits. So there was no PDF datasheet available, but there was a number of images on the AliExpress store. So I've kind of condensed them down here. So here we can see the body is 3.2mm by 2.8mm and the lead wires are about 5.9mm. The leads are kind of in the center. So if you're going to mount these on a printed circuit board, you're going to have to drill a hole or root out a little square so the LED can shine through or shine out of the printed circuit board. Standard 4 pins on most Neopixels. One gotcha on this document is that there's a chamfer here on the lead wire, which is designated as ground on this one here. The chamfer is wrong. The chamfer shouldn't be here. It should be on this side over here. So here I've mounted a number of different Neopixel compatible LEDs showing, so you can see the different sizes. So here we have a 50-50. These first two are 50-50 LEDs. This is the original WS2812, which has 6 leads. So it's a 5mm by 5mm surface mount component. There's also a WS2812B compatible. So that's got 4 leads. And this one in particular is actually a RGB white LED. There's also a 35-35. So it's 3.5mm by 3.5mm. And it's got a more complicated surface mount pattern on the underside. So this is the new SK6812MINI-E. So you can see it's a 3.2 by 2.8, and you can see that the lead wires are almost 6mm. This is a 40-20. So this is a type of LED that shines. In this case, it's going to, for this top one, it's going to shine at the top of the screen. So it's a 4 by 2mm. This is a 20-20, so this is a 2mm by 2mm. And there's also a 15-15, so that's a 1.5mm by 1.5mm. So I also have a 5mm LED here. So the Mini-E looks like it might be a really good option for kitting. So I just wanted to show how relatively straightforward it was to solder these, where I was going to solder wires directly onto the LED. So as I said, the LED has a chamfer on the body and on the lead wire. So that's going to be the ground. And so all you're going to need is going to need a standard soldering iron, standard solder, a pair of tweezers helps. And I have a bit of sticky tape here that helps to hold the LED. And now I have an Arduino connected up to these crocodile clips, which goes through a test pattern. So black is ground, red is our positive voltage, and white is our data in. There, let's go through the sequence. So the LEDs seem to be fairly robust. They seem to be quite tolerant to temperature. It's nice and bright. I've also mounted some of the LEDs onto strip board where you have to cut a hole. Where I kind of made a hole in the printed circuit board. So I've used wire to join the pads together and connect the traces. So in the description below, I'll provide an affiliate link to where I purchased the LEDs. The vendor, as of kind of January 2020, was selling 100 LEDs for around €10 delivered. And they only took about 12 days to get from China to Dublin. I think these were going to be a very good option for anybody who's making shitty add-on boards or other kind of kits for selling on places like Tindy. Okay, thank you. Bye bye.